And speaking of joints, one last thing that I want to touch upon for advanced motion or advanced ways of controlling the robot is how so far everything that we've done is working with the robot in Cartesian space, in X, Y, Z coordinates of the robot, right? But it turns out that the robot is a mechanical device that has 6 joints. It has the base, the shoulder, the elbow, and then it has wrist 1, 2, and 3 here, right? Can you see that right now? Not greatly. Anyway, let me move the robot down so that we can see better. All right. So again, base, shoulder, elbow, and this is wrist 1, 2, and 3. All right. Turns out that these joints, these axes, are controlled with angular degrees, angular motion, right? And when we type here, move to somewhere in X, Y, Z, the robot makes some calculations to figure out what the angle of each one of these axes should be. That's what's referred to typically as inverse kinematics, but we don't really need to get into that. What's important is that we can, for whatever reason, we may want to choose to work directly with the values of the angles of each one of these axes, right? If that's the case, then we can do that in Machina with the axis action, right? Which also has relative and absolute mode. So for example, let's say we wanted to home the robot, to bring it to like a very square position, like this, but we don't really know where in X, Y, Z that position would be. For this particular robot, for universal robots, it just so happens that this position, a home position, is going to be with the following values that I'm going to write here. I'm going to set the value of the axis to, is going to be an absolute motion, to the values that I'm going to specify right now. For this robot, it's going to be 0 for the base, is going to be minus 90 for the shoulder, minus 90 for the elbow, minus 90 for the first wrist, and then it's going to be positive 90 for the second wrist and positive 90 degrees for the third wrist, this one here. Yep, it's a little bit weird, don't ask me why, but that's how these particular robots work. If I do this and I hit enter, you can see that the robot moves, not linearly, moves to a very squared position based on multiples of 90 degrees, right? I could do the same, but instead of 0 here, I could rotate the base 10 degrees, right? And then, you see, or to minus 10 degrees. And the robot goes that way, all right? But I can also work incrementally. Instead of in absolute values, I can say, well, I want to increment the current values of the axis by whatever number. So for example, let's say I want to increment the value of the base by 20 degrees, and then the rest are going to stay to 0, right? So the robot moves 20 degrees this way. Let's say I want to increment the value of the third wrist by 45 degrees. So axis, no 2, 0, 0, 0, then 45 degrees, 0, and 0. And that's going to move the robot 45 degrees. And now, imagine I was drilling something, so I wanted the robot to screw in. That is the 6th axis. That is the third wrist. So that's, I can rotate that, for example, axis 0, 0, 0, 0, and then the last one is going to be, for example, I'm going to increment 90 degrees, right? And then you can see, all right. And I can always go back home by setting the axis to 0, minus 90, minus 90, minus 90, and then positive 90, positive 90. Like that. And now the robot is in a home, nice position to start working with. For the sake of safety, one last word of caution. Make sure if you work with the values of the axis of a particular robot, make sure before you do that, that you understand what are the values for a particular home position in whichever robot you are working with, and make sure you also understand the limitations of those angular values, because robots cannot rotate infinitely. So there is only a certain range of angular values in which each one of these axes can move between. All right. So make sure you check what those are for the particular value, for the particular robot that you are working with. All right. Stay safe.